I have 1 o'clock on my time, so I think we'll go ahead and get started. Hello and welcome to New EPIC's UST Inspector Training Webinar. I'm Drew Youngs. I manage New EPIC's UST and LUST programs. Nick Bissonette of New EPIC will also be helping with facilitation of today's webinar and Q&A. Today's webinar is the first in a 4-part series of webinars New EPIC is providing that build off of the themes planned for the now postponed National Tanks Conference, which was rescheduled for September of 2021. Please be on the lookout for future announcements related to this webinar series. Before we get started, I'd like to go over a few items so you know how to participate today. We've taken a screenshot for you of the attendee interface, and you should see this on your own computer in the upper right corner. You're listening using your computer's speaker system by default. If you'd prefer to join over the phone, just select telephone in the audio pane, and the dial-in information will be displayed there. We encourage you to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We'll have a short Q&A after each speaker's presentation, as well as a longer Q&A at the end of our webinar as time allows. Please address all questions to a specific presenter. A little bit about New EPIC's Tanks program. We work to provide training and information exchange opportunities to state and tribal UST and LUST personnel. In partnership with EPA, New EPIC collaborates with state, tribal, territorial, and federal regulators to reduce the overall number of UST releases and to minimize the impacts of LUST to the environment. Our ongoing webinar series, LUST Line Bulletin, and the National Tank Conference are a few of the ways we provide engagement to keep the tanks community well informed and connected. Today's webinar will focus on emergency power generator UST systems. We'll have an EPA update on UST regulatory requirements as they relate to the emergency power generator UST systems. Next, we will get to hear a state's perspective of lessons learned from regulating these systems. Finally, we will discuss considerations for emergency power generator UST systems, including design and installation. In the handout section of the GoToWebinar panel, you'll find a copy of the slides for today's presentation. New EPIC will be posting the slides and the webinar recording to our online archive for future use. After the completion of today's webinar, you'll be automatically prompted to an evaluation form. Thanks in advance for providing your feedback. An electronic certificate of attendance will be emailed to the address used to register for the webinar. Please note that today's presentation has not been evaluated to meet any continuing education requirements. And with that, I'd like to go ahead and introduce today's speakers. Carolyn Hoskinson has served as Director of EPA's Office of Underground Storage Tanks since February of 2009. Prior to that, Carolyn served as the Deputy Office Director beginning in August 2006. As Director, Carolyn oversees OUST's responsibilities for ensuring that the nation's hundreds of thousands of underground storage tanks are designed and operated to protect the environment and prevent leaks. OUST also ensures that leaks do occur are detected and cleaned up as soon as possible. Tim Smith is a member of the Release Prevention Division at US EPA's Office of Underground Storage Tanks. Tim has been with OUST since 1998. Tim is OUST's point of contact on issues related to release detection, UST compliance inspector training, operator training, and inspections. Tim is also the team leader of the National Work Group on Leak Detection Evaluations, Interstitial Monitoring, and Out-of-Tank Detector Methods team. Seth Hendricks has 14 years of experience working with state and federal UST regulations. Seth currently works for Montana DEQ as an environmental protection specialist in the underground storage tank program. His work includes UST installation construction permits, UST inspection, UST compliance, and enforcement. In the past, Seth worked for the Nez Perce Tribe Water Resources Program and the UST program, Brownfields program, and Leaking Underground Storage Tanks Cleanup program. Finally, John Signata, principal of DataNet Engineering, a specialty fuel systems engineering and construction firm, is a NACE corrosion specialist and a cathodic protection specialist. He's accredited as an API 653 tank inspector and an STI SP001 tank inspector. In the field of non-destructive testing, he is a level 2 UT engineer per S&T TC 1A. He is also a voting member of NFPA 30 committees on combustible and flammable liquids. Dr. Signata is a graduate of the U.S. Air Force Academy. He served in the Strategic Air Command as a B-52 pilot and later as a fuel system engineer. He has over 40 years of experience in fuel systems. So before we begin with today's technical presentations, I'm happy to introduce Carolyn Hoskinson, Director of EPA's Office of Underground Storage Tanks. Carolyn?
Great. Can you guys hear me?
Sure can. Welcome.
All right. So the first thing I wanted to say is I really wish we were looking forward to a National Tanks Conference this September. We had been hoping to get together with everybody live and in person and be actually seeing each other, but of course that's not going to happen. So we do still look forward to having the National Tanks Conference in September of next year. Same place, same location, same actual dates even almost. For those of you who are of a certain age as I am, you might be thinking of same bat time, same bat channel, but just a year later in September. So I really hope we'll be able to see most, if not all of you there in September 2021. But in the meantime, we decided to do what we could to get folks together, which was to have a series of webinars. And hopefully they will just be whetting our appetites for real in-person conversations that we'll have together in Pittsburgh next fall. So this session on emergency generator tanks was one that we were planning to have at the Tanks Conference. And I'm sure that we'll have a great discussion today. And a year from now, next September, there will probably be even more to talk about emergency generator tanks. So I'm sure we're not stealing the thunder from the Tanks Conference for next year. And as mentioned just a minute ago, look out for additional webinars to be coming up on topics on lost cleanups, on state funds and financial responsibility, and maybe some cross-program topics. So we hope that this webinar will be a good experience for you, and we will have you join us on our future webinars on additional topics, just as a way to try to stay in touch. And so before I close, I just want to say that I hope everybody listening out there is doing well, and that your families and loved ones are doing well too, and you're like the rest of us, taking this experience one day at a time and doing the best you can. So my best wishes to all of you, and I look forward to hearing the presentation on emergency generator tanks. Thanks, everybody.
Great, and thank you, Carolyn. And now at this point, we will start with our first presenter, which is Tim Smith. And Tim, I will go ahead and give you make you the presenter.
Alrighty.
Whenever you are ready, you should be good to go.
Great. Can you hear me?
We can hear you, yes.
Great. Do you see my slides?
Yes, we do.
All right, I have control. Good afternoon, everyone. My name is, of course, Tim Smith. Today, I'd like to cover 5 main areas in my presentation. The first and foremost is that the deferral has ended. Hopefully, everyone on this call is aware of that. Otherwise, this is probably going to be a very long and painful webinar, at least for me. The second issue I'd like to talk about, or area I'd like to talk about, is determining if the power generator systems are regulated by our program or not. So I'm going to take a 30,000-foot view. I'm not going to get into any of the gory details. There's so many different system configurations, it would probably take another 3 or 4 webinars, if not that, if not more, to really go into major detail on how to spot these changes and what to do with those. The third area I'd like to talk about is I'm going to take another high-level view of release detection requirements and methods that are applicable to these systems. The fourth area, I will talk about really quick some features of these systems that present a challenge to meeting federal OUST release detection requirements. I will end with my list, just a short list of resources that are available and some on the way by EPA and the work group that has been formulated to address the issue of emergency power generator OUST systems. But launching into my first topic here, it's the deferral. It's no longer applicable to these UST systems. The original federal UST regulations in 1988, they deferred these systems from the release detection requirement. That deferral was never intended to be permanent. The systems were not excluded or exempted. They were merely deferred to address technical issues at the time. Those technical issues, they centered around, for the most part, the remote locations of these emergency generator tank systems, sometimes associated with the towers at communication towers and things like that, even even hospitals. At the time of the proposal, there was that need for EPA to establish different requirements or tweak the requirements for release detection that were applicable to typical systems or traditional systems, more focused for the emergency power generator systems. But lo and behold, in November of 2011, based on information that we received and getting the regulatory process underway, we discovered that about 30% or so of the emergency power generator systems were already regulated across the nation. That was due in large part to a number of states not deferring these systems. We did learn that, unfortunately, those systems, not like the 88 timeframe, they weren't smaller systems in the 100-gallon capacity. These things have grown to huge systems where the storage capacity is in the tens of thousands. That is due in large part to a number of requirements, probably post 9/11, where capacity for hospitals, et cetera, they have a 48 or 72-hour runtime that to provide emergency power in situations. But based on the comments that we received during the reg process, we did come up with a number of comments and we responded to those comments. In general, the comments centered on the release detection requirement for piping. There were a number of concerns with owners and operators, very worried, of course, as EPA is, that these systems be shut down or the submersible pumps shut off to meet the release detection requirement. EPA identified in the preamble, as well as our response to comments, that is definitely not EPA's position. There are three ways, of course, for the line leak detector requirement to be met: shut off the submersible, the slow flow, and using an audible or visual alarm. We hinted and really drove people to really look at that particular option to meet the release detection requirement. Overall, the feedback that we received and the knowledge that these tanks, these systems had storage capacity in the tens of thousands, there was no need for us to any longer keep the deferral in place. We lifted that deferral, and the 88 deferral is no longer applicable to emergency power generator systems. These systems are required to have full release detection for new systems that are installed after October 13, 2015. According to the federal requirements, they have to have release detection at installation. I'm going to back up a couple of steps and make sure that you guys understand the dates and other information that I'm providing in my presentation. They're applicable or with respect to the federal UST requirements, 40 CFR Part 280. There is likely variation amongst states as to what their compliance dates are for meeting the release detection requirements for these systems, but you'll have to check with your implementing agency to ensure that you're meeting the state-specific requirements. But this is that 40 CFR 280 based presentation. So the older systems that were installed prior to that October 13, 2015 date, EPA provided a 3-year time frame for owners and operators to retool their systems to meet the release detection requirement. So as of October 13, 2018, the older systems had to meet the release detection requirement. So let's take that 30,000-foot view of determining whether a power generator system is regulated or not. I'm going to give two main considerations, and we can dissect it from there. First consideration is, does the power generator system, and I'm not calling it an UST at this time because we don't know if it's an UST. If you do, you have to do the calculation. You have to look at the definition of an UST, and it's provided by statute and in the regulations. I'm going to read it real quick so that we're clear. The underground storage tank, or UST, means any one or combination of tanks, including underground pipes connected thereto, that is used to contain an accumulation of regulated substances, and the volume of which, including the volume of underground pipes connected thereto, is 10% or more beneath the surface of the ground. Now, looking at that, one very important word to pay attention to is that one or more combination of tanks. That phrase right there, and this word in particular, tanks, the definition does not single out underground tanks, does not exclude above ground tanks. This definition includes above ground or underground or below grade or above grade. I'll try to refer to them in that context, above grade or below grade. But looking at the total system and doing your calculation, you look at all of your capacity to look at the total system to determine the complete volume. You look at and you add up the volume for your underground or below grade tank, the volume for your above grade tank, any volume in this underground line. You do not include, in our program, we never include the above ground connected piping, but at this transition point, you would make the determination from this point to your tank, the volume of the underground or below grade line. Doing all of that, that gives you a tally of your total system volume. You would, of course, take the volume of your below grade components, that volume within those, and that divided by the total would give you, multiplied by 100, would give you the percentage of your system. If that percentage is 10% or more, that is a regulated system by the federal UST requirements, 40 CFR 280. That means that that system would be regulated under the federal UST requirements. Just eyeballing this is not the scale, but clearly this below grade volume, it's quite more than that 10% looking at the total volume here. So this depiction here is a representation of a system that is regulated by under the UST program. We also, for purposes of main considerations, you would look at whether the UST system, you've determined at this time that it is an UST system. You are not done. You would determine if there are any regulatory exclusions that apply. Most likely the ones on this list, this is not all inclusive, but the ones on this list will not apply. If it's a farm tank or residential, of course, it's excluded from the regulations, but due diligence to make sure you're complete you would definitely do an assessment and make sure that none of these exclusions apply. Septic tank, of course, is not ours. Flow-through process tanks, not ours. But this other list here of potential exclusions here are more likely to apply. Two major ones in particular, the heating oil exclusion. If the UST system is containing a product, a heating oil or a substitute noted in this, and I've provided a link to the EPA's flow chart on determining if the heating oil exclusion is applicable or not. Backing up again, another step, I just wanted to state that this presentation will be available very shortly after the webinar. New EPIC usually gets it up about within a week. But this is a pretty long URL. You don't necessarily need to copy it. Folks in the program familiar with it, using it since the inception of the program, or basically the early 90s, and might already or should already be familiar with it. But this presentation and this webinar, the presentations in the webinar will be made available shortly after the webinar. So looking at the heating oil exclusion, if it's a heating purposes on premises, that UST is not regulated. It qualifies for the exclusion. For purposes of power generation at a hospital, to provide lighting in case of emergency, those are not applicable. So those systems that are used solely for the generation of power, will not qualify for the heating oil exclusion. The second main category of exclusions here, underground exclusions area, might apply to the systems that you evaluate, or as an owner and operator, your system might apply or meet the exclusion. And that is a system, and stay with me here about the entire system. It's a system approach. That entire system, you scroll back here, that includes the underground, below grade tank, below grade lines, and this above grade tank. That whole system would have to be in a basement or cellar, mine working shaft or tunnel. No portion of any of the tanks can be beneath the surface of the ground or otherwise covered with earthen material. If it isn't, it does not meet the qualifications for the exclusion. So having that above ground tank here, just potentially above grade or even in a basement, everything would have to be in a basement to qualify for the exclusion. So that's a very important point to keep in mind when going through the determination whether the underground exclusions area applies or not. Moving to the third main area I want to cover, it is what are the release detection requirements and what equipment or methods can owners and operators use to meet the requirements. As a result of the federal compliance date of the secondary containment and interstitial monitoring requirement, this date is probably the last in the country here. Most states have a date that predates this because of the EPAC of 2005. So this is pretty much the last date of compliance with the secondary containment and interstitial monitoring requirements. If the system was installed on or before this date, all methods of release detection, that's the APGs for tanks, SIR, CITLB, all of those are acceptable for use with those tanks. The pressurized piping requirement, all of those methods, that line leak detector, the line tightness test, plus the automatic line leak detector, plus either the line tightness tests or another method that covers the lines would be acceptable for use. But if that system was installed after April the 11th, 2016, then of course, only, they have to be secondarily contained, but only the interstitial monitoring as the primary method of release detection is acceptable under the federal UST regulations. So looking at the requirements here in a graphic form, this graphic has been presented in a number of EPA publications. It just shows in situ where these release detection methods are used in the system. This list that I provided here is just a shotgun approach to the tank options and piping options. The monthly requirement for tanks are applicable. Again, interstitial monitoring after that April 11, 2016 date is the only method that can be used. Owners and operators may back up their systems or use duplicative release detection or backup systems, but primary is interstitial monitoring for the release detection requirement. You also have you have the piping requirements here. For your suction piping, a number of these systems are still suction systems, but with those larger capacities, they switched over for the most part to, or for a large part to, pressurized piping systems. But if it meets the safe suction system, a European suction system, no release detection is required. There has to be that proof, of course, of verification that meets the European or safe suction setup, but no release detection is required. Otherwise, the 3-year line tightness test or a 30-day piping monitoring release detection method is required. We're familiar with the line leak detector requirements for pressurized piping. There's that dual requirement. They have to be met. In addition, the 2015 federal UST regulation required some additional release detection equipment testing. On an annual basis, owners and operators have to test their systems in accordance with the manufacturer's requirement, a code of practice, or the implementing agency's requirement. The manufacturer's requirement, the code of practice, you have to cover the minimum federal regulatory requirements. If a manufacturer's requirement or code of practice does not address one of the listed items or components that at minimum has to be met, then that code of practice or that manufacturer's requirements is not sufficient by itself to meet the entire regulatory requirement. So owners and operators would have to, in that case, if say the manufacturer leaves off a component that is required, owners and operators would have to augment that manufacturer's instructions with a code of practice or the implementing agency's instructions on how to meet those requirements. So I want to move on to my fourth area that I want to cover today. I want to talk about real quick a 30,000-foot view of the features or really the components of emergency power generator UST systems that present a challenge for meeting release detection requirements. There are 3 in total that I want to focus on. There may be more, but these, I believe, are the most probably problematic or urgent to address. Not only are these components part of these systems, and they're not part of traditional UST systems like at C-stores, but there are some regulatory requirements and code of practices that apply that provide or present the UST program with some challenges or owners and operators to meet not only the UST requirements, but these codes of practice and requirements in those codes of practice. The generator itself, that's not something you see typically at a C-store. The day tank, above ground tank, typically it's not something you see at a C-store. I say that, and probably one of the questions that I'm going to get in the very near future is I went on a couple of inspections at high throughput facilities, and I see some above ground tank, but we will couch that for now. We can talk about that later. But for the most part, you don't see a day tank that's designed to feed a generator at typical facilities or traditional facilities. Those are quite prevalent at the emergency power generator systems, and they come with some issues here. The issues being, in particular, the National Fire Protection Association requirements for these two components here. Now, the National Fire Protection Association in 2016, shortly after, as it happens, the final regulations were promulgated. There was a addition to NFPA 110 that EPA became aware of. We actually didn't become aware of it until about 2018. But in 2016, there was a restriction or conflict in a couple of sections in NFPA 110. NFPA 110 section 7913 basically says no valves in return or supply lines. But in section 5.6.3.2, it mentions solenoid valves where used must have non-electric operator or manual bypass valves. For all intents and purposes, I'll cut to the chase. If owners and operators want to comply or have to comply with NFPA 110 requirements, they're not all applicable in every state or every jurisdiction. But to comply with the UST requirements, looking at and meeting the requirements for section 5.6.3.2 will meet that requirement. And what that means is owners and operators would have to use a solenoid valve or some valve that is a non-electric operator or a manual bypass valve. They just obviously don't want you to shut the system down without having the ability to manually, get the flow of product in an emergency situation. EPA is 110% behind that notion. So to comply with 110, comply with section 5.6.3.2 as applicable in your jurisdiction. I want to also talk about this day tank and the connected lines here. Again, the above ground tank or above ground lines are not regulated, but these systems have what you can see is a return line. In this case, it's an overflow line from the day tank. That is another issue here in NFPA, I believe 37, has a restriction for having a valve in the overflow line where they definitely don't want product to not be able to flow back into the main tank from the day tank. In order to meet that requirement here, EPA, we looked at, we were asked to look at the gravity feed lines, and the issue of gravity feed lines addressed, for all intents and purposes, the NFPA 37 restriction, if you will, where looking at this line here, I'm going to use two diagrams to talk through this. If you look at this configuration of piping here, this is the return line coming back from the day tank. It is pressure assisted. This product comes to this point, and for all intents and purposes, it flows back by gravity from this point back to the main tank. As long as there's no obstruction to prevent that flow back into the main tank, EPA views this line right here, this section that's regulated. Again, the above ground lines are not regulated. This below grade line is regulated. So from this point basically back, that's in the federal program. That's our requirement or our jurisdiction. There's no blockage back to that. EPA views this as non-operational component. This is again akin to a fill line. It's basically a refill line from the day tank back to the main tank, if you will. Despite that pump that may be assisting this, and this being considered as a pressurized line by some, that pressure to get it to this point is of a pressure or quantity that still does not cause problems for viewing this line as non-operational, not routinely containing product, unless the system or when it kicks on, usually tested on a monthly basis or weekly basis. This line is typically not, does not routinely contain product. This, I want to compare this configuration of the lines going back to the main tank to this configuration. Even though this line right here, it's pressure assisted and it pushes from the day tank that product back to the main tank, there is that blockage here where there could be product that sits here in the return line and it does not flow back to the tank. It could get stuck here. This right here, because of the configuration of the piping, this return line is not a non-operational. This could routinely contain product, and this configuration of the return line has to meet the release detection requirements for pressurized line. In addition, the supply line, it's always regulated here. Usually have a submersible pump pushing this product quickly to the day tank in a pressurized situation. So suction system, again, the safe suction and all of the criteria have to be met for safe suction, may not have to have release detection. But wanted to point out these two differences in the configuration. Falling straight back, even pressurized, this is non-operational. If you don't have that flow immediately back or no obstructions, such as a bend here, then you have to regulate it. It's regulated. Owners and operators can reconfigure this setting here or configuration to resemble this, to where the product is flowing back. That's one way of doing meeting the release detection requirement, but all of the other allowances are there, or options are there. I want to end by covering the available resources and talk about some resources that are in the way by EPA and the Emergency Power Generator UST work group that's developing a lot of this material here. Of course, you guys are familiar with Straight Talk on Tanks. That is an overarching and compilation of release detection requirements and release detection methods that are applicable to UST systems, including the Emergency Power Generator UST systems. We have, of course, the UST Technical Compendium. EPA recently added 3 specific Q's and A's on Emergency Power Generator UST systems. They include the assessment of how to make the determination of the 10% if that threshold is met or not. It goes into much more detail than what I provided. We also, in one of the Q's and A's, the new Q's and A's, we talk about the NFPA requirements and how to meet those. Goes into much detail than what I provided in the brief presentation I gave. And it also talks about gravity lines and the non-operational components, how to address those. We also have under development, and hopefully can have this out shortly after some peer reviewing, an AIM system guidance. This guidance is designed to address and push forward that whole discussion about can some sensors be used to meet the pressurized piping release detection requirement. That guidance identifies 3 categories of AIM systems. AIM systems are automated interstitial monitoring or continuous monitoring systems by another name. Those 3 categories have specific or differing requirements, and the requirement or category for using a liquid detection or detector, such as a sump sensor, it has its own set of criteria, will have its own set of criteria. Also, another document that EPA is working on, the work group is working on, is a specific guidance to help owners and operators and the implementing agencies in the release detection requirements. We're going to delve into, not give you this is what we recommend, we can't do that, but some of the release detection like groundwater vapor monitoring, even though they're available by regs or the feds, they may not be the best choice for owners and operators at emergency power generator systems. We're going to delve into specific guidance on meeting the release detection requirements. EPA is exploring maybe a broader assessment or other release detection methods that could be applicable to those day tanks that are situated above ground, more of a visually based release detection requirement. In addition to probably the manual tank aging that will probably get a resurgence on meeting the release detection requirements for those day tanks or other above ground tanks that are part of the UST system. Finally, we're developing a broader guidance that will cover the applicable federal UST requirements such as corrosion protection, the spill and overfill requirements, in addition to the release detection requirements, but giving you a guidance document or the public a guidance document similar to airport hydrant system and field constructed tank guidance that we provided. And so with that, I turn it back over to you, Nick, and I think we might have time for a quick Q&A.
Yes, great. Thank you, Tim. Appreciate that. Probably in the interest of time, we'll be able to take over one question. And I'll just make myself the presenter. And the question is, does the volume of the above ground piping figure into the total system volume? For example, if a long run of above ground piping holds a significant amount of fuel when associated with a small UST, could it push the tank into not being considered a UST?
The short answer is no. Hey, can you give me control back, Nick? I want to bring up that diagram I had real quick. Sorry about that. Or do
maybe
I have
can
control still?
Maybe I can go to it quickly.
Yes, go back to keep going. Sorry about this, guys.
Further.
Keep going. Further, please. There you go. Stop. Okay, go back. All right. Looking at the diagram on screen, it's coming up shortly. This above ground piping, whether it's 10 feet to 10,000 feet, none of this piping is regulated under the federal UST requirements. This volume in this piping does not is not included in that determination, that 10% determination. Very good question. There are some situations where this piping runs up to the 10th floor, for example. It is behind concrete. That's still not underground. That piping run, whether it's 10,000 feet up to the 100th floor, going to the day tank on the roof with the generator, that piping does not factor into the consideration whether this is an UST system or not. And that piping does not have to meet by the requirements of federal UST 40 CFR. It does not 40 CFR does not apply.
Okay, great. Thank you, Tim, so much for that. And we will go ahead and give it over to Seth now. I will make you, I'll give you controls of the presentation now. And whenever you are ready, you should be good to go. Oh, hold on, it might be muted, Seth.
Yeah,
Okay.
I just unmuted. How's my voice sound? Is it clear and crisp?
Sounds great.
Okay. Actually, my controls, let's see. Yeah, I guess they're working now. Perfect. Thanks. Hope everyone's safe and sound today. In the Big Sky State, Montana, we have a nice, clear, sunny day. So perfect day almost. When we started talking about the emergency power generator tanks, we actually had, in doing this webinar, we had some big snowstorms really late in the summer. So we're thankful for sunshine now. My goal with this presentation is to build on the federal, what Tim Smith so eloquently talked about with the federal regulations. And full disclosure, I've been watching a lot of The Last Dance on Netflix. So if Tim's presentation was like the Michael Jordan, I'm just hoping to be kind of like the Scottie Pippen here and talk about how things are applicable to the state of Montana, how we've addressed emergency power generator tanks, and we also connected with and borrowed some scenarios from South Carolina. So we thought, having maybe working cooperatively and networking together, we'd have a couple states. But folks, if you're another state or territory that's just starting to implement the regulations, that you'll have something to start with and see what we have done. So Montana DEQ UST program regulations. The start of the program was November 1989. So we're a year or so after the federal program started. And an interesting thing, with emergency power generator tanks is you're looking at something like this. And if you're used to, just inspecting convenience stores, gas stations, your typical underground storage tank system, these systems look a lot different. And so hopefully they're very unique. And so hopefully we can help you out with implementing, federal state regulations. So a few differences just to show some of the background in Montana, the Big Sky State, versus the federal program. Our program, we started regulating emergency power generator tanks, including the tank and piping leak detection, 1989. As you know, the EPA deferral for the leak detection was 1988. We also, in Montana, decided, it's not because we weren't good at math, but we decided rather than using EPA's 10% rule for determining a lot of the piping systems in Montana, we decided to write the regulation and basically generalizing this, but an underground regulated petroleum pipe or regulated product pipe in Montana of any type that is underground is regulated. So this includes above ground storage tanks that have connected underground piping. So basically that gives us a lot more, like the terminals, things like that, EPGs, above ground, underground piping systems, and, like marinas and things like that. So we also decided, in December of 2010 to also add on a shutdown requirement for tank and piping leak detection methods to ensure the UST operator is alerted immediately and is forced to address all possible leak alarms. So this is something on top of the standard federal 3.0 gallon per hour catastrophic method. We also included, if you're using like PLDs or ELODs for your monthly method of piping leak detection, but if you're doing a 0.2 monthly, that you have to program your tank monitor to shut down on a 0.2 gallon per hour ELD line test failure. And also, as far as the tank, if you have a double wall tank with an annular interstitial liquid sensor, discriminating or non-discriminating, you would have to program the ELD to shut down the dispensing system. And Montana also decided recently to phase out all out-of-tank leak detection methods. This we added in the federal 2015 regulations, which ours are 2018. And we did a 5-year phase out ending October 2023. So groundwater and vapor monitoring will no longer be a valid method of tank and piping leak detection. Some more differences. Montana, we also issue UST construction permits. So anytime one of our licensed individuals wants to modify a system, install a system, remove a system, and basically a permit is required, so we can let on the permit put all the requirements that we have on there. Even though we regulate above ground tanks with underground piping and associated underground piping, we don't currently have an SPCC program like the federal program. And so that's something that we currently don't implement and regulate. But ASTs are eligible for the state financial responsibility fund. And so Montana has a state petroleum tank release cleanup fund with board members, which is the most common method of financial responsibility for UST facility owners. Another thing we added on to the regulations, and this was in 2011, we added on anti-siphon requirement, specifically to address some of these systems that are unique with above ground tanks, underground piping, EPGs. Basically, I believe this came from the fire code, and we decided to add it into our regulations as well. The owner operator of enough system that is located at an elevation that produces a gravity head on an underground piping system shall ensure that the product pipe is equipped with one of the following devices. And this would be a department approved anti-siphon valve, department approved normally closed solenoid valve, or another department approved device designed to prevent siphoning. So this is from PEI, and it shows a mechanical anti-siphon device on the left with a suction pump or suction dispenser. And then on the right, you have a submersible turbine pump. These are both ASTs, and you have an electronic solenoid valve to meet the anti-siphon requirement. And the one on the right is strictly a pressurized system. The one on the left is a suction system with what we call in Montana a static pressure head. So we do view both of these systems as, quote, pressurized piping and require double wall piping for both of the systems with a monthly method of piping leak detection, unless they choose to do an annual 0.1 line tightness test. Typically, both of these systems would have double wall piping with sensors programmed to shut down the dispenser. And then you also have on the right a line leak detector here versus on the left you don't have that. So for your catastrophic piping leak detection on the left, you're actually typically using that liquid sensor, discriminating or non. So that's the general order on the right with an STP showing the solenoid valve before your ALLD, and that could be a mechanical line leak detector or electronic line leak detector installed there. It shows like an adapter fitting or what we call like a T housing. We'll get into more detail of that later, but basically I just wanted to show you some unique piping situations that we addressed, and these kind of situations would apply also to emergency power generator systems. So we were a little late to the party on the farm tank exemption. The EPA and the federal regulations were effective, I believe, in 1988, where Montana, we did our exemption in May of 1995. So we exempt underground farm and residential non-commercial motor fuel and heating oil storage tanks of 1,100 gallons or less, which were installed before April 27th, 1995. But we also gave the owner-operator the option to opt in the program, and then they would be eligible for the State Petroleum Release Cleanup Fund as far as the state financial responsibility mechanism. I included just kind of a schematic of what we've used in the past for a decision tree to kind of determine if they're eligible for this exemption. Obviously, the main question, are the contents consumed on the premises where stored? And Tim also noted that. So for an inspector in a state, all of a sudden you have to meet the new requirements with emergency power generator systems and owners and operators as well. So we're going through this period of change, and change is tough for most folks out there, and it seems like specifically even harder for owners and operators. Once they get into a plan and a system, it's hard to change. And that kind of relates to like The Last Dance, watching on Netflix there with Michael Jordan, Scottie Pippen, Dennis Rodman, all kinds of different personalities. And at some point, Michael Jordan was scoring a lot of points, but not necessarily winning all the championships. So when Phil Jackson came in, he changed things up, and he wanted to take the ball out of Michael Jordan's hands a little bit and move the ball around more. And that way, they called it the triangle, have a lot more options for folks to play off the ball and things like that. And it's kind of like what we're going through with emergency power generator systems. A lot of personalities out there in the owner-operator world, and so we have to kind of be team players, work together in these times of crisis. And nice thing about in times of crisis that lots of innovation occurs, and so we'll get through it. We'll be successful. Unusual facilities in Montana, health facilities, lots of detention centers, prisons, ski resorts, schools, hospitals, Department of Defense, Air Force, missile sites, and silos. So a lot of unusual facilities we're taking on. In the past, with the federal system, you would show up to do an inspection. You wouldn't have to worry about tanker as far as the piping leak detection or the tank leak detection. And so now we're changing that, and we have to address that. So it's time to check in. We got some few schematics for you on U.S. suction piping systems. In Montana, we refer to supply and return piping, just generalizing it as U.S. suction. These systems can be suction, gravity, pressure, suction typically being less than atmospheric pressure, gravity equal to atmospheric pressure, and then obviously pressurized systems more than atmospheric pressure. So I just have, we with the states, we always go back to the federal technical information that they provide. So this is kind of just from that, the technical compendium on, the difference, what are the regulatory requirements for suction piping. You got your safe suction piping on top there where the piping has enough slope that the product in the pipe can drain back into the tank when suction is released. And the piping has only one check valve, which is installed as close as possible beneath the dispenser or the pump. And then you would have to verify that as the inspector via visual or installation records. If the suction line doesn't meet those items, it's not safe suction. And so you're into kind of a standard suction or possibly, even possibly pressurized. But if it doesn't meet the safe suction requirement, then that suction line, a line tightness is required at least every 3 years, or you can do monthly interstitial monitoring of the piping, or SIRS would be an applicable one. In Montana, we no longer allow vapor or groundwater. We're phasing those out. And of course, each pressurized piping run must have one leak detection method from the set. So if all of a sudden you're into a pressurized or more than atmospheric pressure, then you need an automatic line leak detector, and that can be a flow restrictor like an MLD, an automatic flow shutoff like an ELLD, and you could also refer to like a liquid sensor with required programming to shut down is possibly that as well. And then a continuous alarm system, which we call this in Montana like a Montana auto dialer as it applies to emergency power generator systems. And then you need a monthly piping leak detection method, of course. So for pressurized piping, I wanted to point out that the ALLD must be designed to detect a leak at least as small as 3 gallons per hour at a line pressure of 10 pounds per square inch within 1 hour by shutting off the product flow, restricting the product flow, or triggering an audible or visual alarm. And that's kind of what we call an auto dialer, because we decided instead of requiring the emergency power generator systems to shut down, that we would require them to be notified immediately and address those issues. Other facilities that wouldn't be like a heating oil or EPG system does have to have the shutdown. That's kind of how we do that. And also, so that how that works with an auto dialer is a continuous alarm system which constantly monitors line conditions and immediately triggers an audible or visual alarm if a leak is suspected, like your liquid sensor goes into alarm and detects product in the containment sump. Automated interstitial line monitoring system can be set to operate continuously and sound an alarm, flash a signal at the console, and even ring a telephone in a manager's office when a leak is suspected. Typically, we do the telephone, like an auto dialer, some brand names possibly like a Sensaphone, but they work with an existing leak detection panel like a Veterud or Franklin Fueling System tank monitor as well. We do see some places like detention centers that prefer, instead of a telephone, they have a green or red light that flashes at a 24-hour manned station where there's always an individual there watching that system. So full disclosure on these 5 versions of US suction systems we're looking at, these did come from South Carolina. So thank you to South Carolina for sharing these. They were really well done. And we can kind of show the differences in the 2 states. Montana has some slight differences, and we can go over that. But in this version of US suction system, we have the supply piping with a suction pump and then a generator day tank and then returning to that same tank. Supply is a suction system. Return is gravity system, so operating at atmospheric pressure. Fuel is dispensed at a higher elevation than the tank top. So in the supply line, if only check valve is at the suction pump, then safe suction piping, and that would be exempt from release detection. In South Carolina, they require UST Form 19. We do not in Montana. There's no associated form at this point. So if there was a check valve at the tank, then the supply of standard suction requires a line tightness test every 3 years. And on that return line, the South Carolina actually requires an annual line tightness test, or monthly interstitial monitoring is required. Containment sumps used for the interstitial monitoring also must be tightness tested every 3 years. In Montana, the only difference is on the return line, we require at least a line tightness test on a 0.1 gallon per hour basis once every 3 years, so not annually. And I believe that this would be a non-operational component on the return line for EPA, and that there would be no leak detection required. So Montana, we kind of fall in between EPA and South Carolina. On this next version, we have some anti-siphon valve devices. We actually have a pump, and we have the supply and return with the tank at an elevation over and above the generator. Supply is pressurized. In our view, return is pressurized. Supply requires ALLB and an annual line tightness test or monthly interstitial monitoring. If it has an STP like it looks to be there, submersible turbine pump, in Montana, we require an ELLD to be installed in the system. On the return, requires an ALD and annual line tightness or monthly interstitial monitoring. Both these require double wall pipe. And then in South Carolina, they say if an ALLD cannot be installed, then interstitial monitoring is required with sump sensors wired for shut down the dispensing system, where we allow an auto dialer that not necessarily shuts down, but that would send a telephone call. And you can have the telephone calls listed 1, 2, 3, 4, 5 as far as importance. So they would actually, that auto dialer could call 5 individuals. We see that often on our inspections. This next version is even a little different. So we got kind of situation where Tim kind of showed earlier. Supply is suction, return is gravity, and that's the return outside the building. Inside the building would be non-regulated to us, but the whole system, we do view that return as regulated in Montana, and so do they in South Carolina. So the supply line for South Carolina, if your check valve is at the tank, then supply line is standard suction, requires that line tightness test every 3 years. If there's not a check valve at the tank, then safe suction piping and exempt from release detection. On that return line, below ground portion is gravity feed back to tank. However, fuel would still get pumped through the pipe if there was a leak. Requires an annual line tightness test or monthly interstitial method. So on that return in Montana, we would allow the line tightness test once every 3 years. But because, and the supply would be either safe suction or standard suction. That's the difference there with Montana, EPA, and then South Carolina.
Hey Seth, this is Drew. Sorry to interrupt real quick. I want to make sure we have plenty of time for John. So if you can bring it home in the next 2 or 3 minutes, that'd be great. Thanks. Go ahead.
Okay, sounds good. Version 4, we got a supply line with looks like a submersible turbine pump, and then return day tank with or without a pump and returning to the tank. Supply is pressurized, return is gravity. And so supply line piping is pressurized, requires the ALD and an annual line tightness test or monthly interstitial monitoring. And then the return line, fuel flows back to the tank by gravity once the day tank is full. If pipe has a leak, fuel could still continuously flow out of the pipe. So South Carolina requires an annual line tightness test or monthly interstitial monitoring method. Without the pump, on the return, we would require that 0.1 every 3 years. With the pump, we would require at least a 0.1 annual line tightness test or continuous interstitial monitoring method with an auto dialer. And the last version here, we have anti-siphon valves. Supply is standard suction, return is pressurized, and those are requirements there. I don't need to belabor that, but basically you have a pump pushing product back up to the return. So you have on the return line requires an automatic line leak detector and annual line tightness test. So basically, the auto dialer plays a big function in Montana with emergency power generators, and we allow the auto dialers to be installed to existing or newly installed leak detection panels, automatic tank gauge for these kind of systems that are US6 suction systems that may have pressurized components, but do not have STPs. Auto dialer communication will send all alarms to the concierge station for 24-hour notification response. This is a newly built Spanish Peak Lodge that has an emergency power generator system with the concierge manning 24 hours. just wanted to point out for STPs, we require those ELLDs to be installed, and we can get into more details on that. But for pressurized STP systems that are part of emergency powered generators. So that's basically everything I have for you today. Hopefully it's been a help for other states, territories that are looking at doing tank and piping leak detection requirements and implementing the federal regulations in their state.
All right, great. Well, thank you so much, Seth. I did get one quick question I'll fire off to you before handing it off to John here. So it's kind of a general question, but the question is, what will happen if you don't have an anti-siphon valve? If you could speak to that at all.
Right. So with the diagrams with the above ground storage tanks that have either an STP or a suction dispenser at an elevation where the dispenser is below the tank, you have that built-in static pressure head. So if you had a hole or a compromise in the piping at the low level, without the anti-siphon device, you could in fact drain the entire contents of the tank. And so the anti-siphon device would prevent that. And that would apply to emergency power generator systems as well.
Okay, great. Thank you, Seth. Really do appreciate that. I will transfer the presentation abilities over to John. And John, just to quickly note, we will probably try to end around 2:45. And if it's helpful, I can give you a 5-minute warning when that time does come up. Oh, sorry, you might have been muted, John.
How's that?
I can hear you now.
You can hear me now. Okay, good. I'm ready to go.
All set.
Okay, Nick, thank you for your time there. For those of you who don't know me, I'm John Signata. And what I'm going to be going over is, as a licensed professional engineer, all the issues regarding not just having a tank installed correctly, but also having it maintained, tested, and removed properly. I'm a PE, so the fact is that everything that I'm looking for is compliance with all regulations, all codes, all industry standards, not just one. I can't pick and choose. Doesn't matter above ground or underground. I got to get it right. Okay, as we're going to go through here, we're going to find that most of my EGen, which is a shorthand for emergency generator power systems, a lot of people just use the term EGens, are actually with the piping and the day tanks. We're actually going to go above grade, and I'm going to go over those are where most of the problems are. And usually the issue is there's standard culprits. The installation of the UST, the testing, that's all well known. So everybody's got the UST, fine. We've got an established cadre of UST inspectors, the installers. Everybody across the country is pretty well. We've got certified installers. We've got inspectors and everything who know what they're doing. It's the little EGen tank and the fuel piping. That's where we're at the Wild West. Wild West frequently because it's not enforced. All the codes, all the regulations applying to the above ground piping, above ground day tank. We don't have certified installers in most states. We have engineers and planners who are just cranking out plans and specs, and all they're doing is just downloading things off the internet. The next issue is that we've got above ground components that are often ignored by everybody. Now, the next thing is I want you to appreciate other problems, unlike a heating system. For example, life safety risks to building occupants. If you're not aware, we have one emergency generator fire every 5 days in the United States over about a 7-8 year period. Compromises to the environment regarding fuel spills, yep, they're definitely pretty lousy. But then another critical issue is the degradation of the reliability of backup power. We have that backup generator for a reason. And unfortunately, when it's not available, like after Hurricane Katrina hit, what did we have? We had a bucket brigade bringing fuel up to the roof at Mount Sinai Hospital. Pretty lousy. All 725 patients had to be evacuated. Here's Sloan Kettering Cancer Center. All of the cancer patients had to be evacuated in the middle of Hurricane Sandy. Mentioned by the previous speakers, we had the issue of years ago, they only had a few hour requirement for backup fuel for hospitals. Today, a class 1 medical facility, 96 hours. So we went from 2, 3, or 4 hours to 4 days. And so therefore you understand why we have a massive fuel tank expansion program at hospitals and a variety of other facilities. Here's a quick list of fuel releases in hospitals. I just went down internet and just find a diesel fuel leak at a hospital. Some of these were absolutely amazing. Picture a hospital crowded with people going back and forth. Watch the number 2 fuel oil come out from underneath the mechanical room doorway and go down the hallway with people tracking it all through the place. It's really nice, especially when it's colored red in a hospital. These are all hospital fuel releases of diesel fuel, big ones. Here's a wonderful shopping mall. You're seeing the shopping mall and all that clear water that's coming down the sides of the scuppers from the rain ports on the top decking of this parking garage. That's ultra low sulfur diesel coming out because that blasted day tank in the center of the photo up there with the guy standing next to it is being continuously overfilled. Why? No overfill control whatsoever on that day tank. Now, these eGen tanks, please appreciate the emergency generator tank has to be located inside the building right next to the emergency generator. We can't have a long distance because of the limitations of the fuel pump on the diesel engine. So therefore, we got to put it inside that building, and that building is being hit by whatever it is, tornado, fire, tsunami, whatever. That's why we have to have that backup power when it gets hit and we lose the grid. Now, emergency generator systems can be extremely reliable if all components are designed, installed, tested, and maintained per applicable regulations, codes, and industry standards. If you have a code and regulatory and industry standard compliant system, you're going to have, first off, a reliable system, and you're also going to have one that you're not going to have to lose sleep over regarding fuel losses. Now, my biggest problem is the people that are installing them and inspecting them. Engineering firms do not have a clue, but they just cranking out plans and specs. Reviewers who are reviewing these plans and specs, they don't know what they're looking for. Last time I took a set of plans and specs for an emergency generator at a large school facility to a county review, their comments were the fence around the fuel tank emergency generator area has to be 6 feet tall. That was their only review of all the plans and specs, was a 6-foot fence. They didn't even look over the piping, how it was laid out, nothing. Building inspectors go out there, fire marshals go out there, police. Fire marshals, what are they typically looking for? What they've been trained on, fire extinguishers and emergency lighting. Unfortunately, that's the limitation. Very few fire marshals go through any of my fuel tank classes. So the next thing is we've got a lot of problems between the piping that extends the fuel from the main tank to the day tank. That's already been addressed by the previous speakers. I just want you to appreciate that those are the weakest links. Those are my fuel pipes where we get the leaks. And now, unfortunately, we've gone over the suction and pressurized system. Please don't forget the overflow and return piping. At some sites I've been, they'd had no clue where those pipes went. And unfortunately, they were not going back to the tank. Here is a depiction of a typical system. Now, again, this is a gross simplification of a typical system. I'm only showing a few details here. Up here, we've got the emergency generator and the motive power. Next to it, we have the day tank. The day tank may be under the emergency generator. We would call that a gen set tank. Otherwise, if it's external, it's still a day tank. That is a fuel tank. Okay, so please, unfortunately, I sometimes have a contractor arguing that a day tank is not a fuel tank. Funny when all of a sudden a 90-gallon day tank all of a sudden overflows with 10,000 gallons of diesel fuel through a hospital, through an office complex, down from the roof, I'm pretty sure we can call that a fuel tank. Okay, so now we could have that one supplied by suction coming up from our main tank UST. That's one way that it could be possibly connected. More and more, we're having, as a result of reliability issues, we're having a submersible turbine pump. My problem with submersible turbine pumps on the issue of release detection is normally we think about an automatic line leak detector installed on the STP. The problem is that frequently will not work as a result of the height difference of how high we are pushing the fuel. An automatic line leak detector, mechanical, typically can only sense 11 feet of fuel. That varies, but that's a good number, 11 feet. If you're going up 3, 4, 5 stories, none of the piping above 11 feet, so in other words, my second, third, fourth, fifth floor of the building, none of that piping is being monitored by the line leak detector from a normal off-the-shelf line leak detector. So please, just because there's a line leak detector does not mean that you have line leak detection. Another problem that we're having is the underground storage tank is not equipped with a submersible turbine pump. Rather, it has a gear pump installed in a doghouse on top of it. The fuel then comes under pressure out of that pump that is above grade, and then potentially goes underground or it goes inside the building and is hidden. That is still a pressurized supply line. Unfortunately, we have a lot of sites where people are going, well, that doesn't count because it's not a submersible turbine pump, or they say that we can't put a line leak detector on a gear pump or a centrifugal that's above grade. That's absolutely false. We can put a line leak detector on any pressurized system, any. Just they're not going to be the typical ones that you see at a convenience store STP that only works with a head of 3 or 4 feet high to push the fuel up to a dispenser. Now, codes. There are a variety of codes that affect the day tanks, the piping that's above ground coming from the underground tank. NFPA 30 is the granddaddy of them all. That's the one where 90% of the meat and potatoes of details of how things are supposed to be installed, tested, maintained, and over protracted periods of time is in NFPA 30. 37, 80, 110, 704 are also very critical for details of properly installing an above ground day tank, as well as the piping that goes back and forth between the day tank and the underground tank. Now, let's look over a bunch of critical headings on the tank fuel piping, tank room, tank venting, and controls and maintenance. Number 1, tank code issues. What is an acceptable tank? It's got to be a UL tank. I'm sorry, when all of a sudden I see somebody welded together a blasted little box and they say, well, it's not leaking. No, that's not a tank. Clearance around the tank is quite critical so that we can inspect it, so we can test it. Tightness testing, again, all my requirements for underground and above ground, as well as the lines, come under the tightness testing regulations for the state. And then we get into our inspection requirements. Now, tank codes. What's an acceptable tank? Up here in this header, I'm literally listing from the most common codes, NFPA 30, which is our standard code, NFPA 1, Uniform Fire Code, IFC, International Fire Code. What are the requirements that we have to have for a real tank? And number 1 is that if it's above 60 gallons, it's supposed to have a label saying that it's UL listed, Southwest Research listed, something like that. It also has to be an atmospheric tank, typically 1 to 2.5 PSI is my rating on it. Now, clearance. Normally we're looking for 3 feet on all sides, which you're seeing on this particular day tank in the middle of this emergency generator complex. It's got plenty of room all around it. All my piping and everything is all laid out, and how the piping extends back and forth. Hey, that's all cool. But here is a more common one. Here I've got a mechanical room in an office building. I got a blasted day tank that is literally pushed into a corner. Everybody noticed the emergency vent. That's one of the engineers there said, well, that's an emergency vent. It's plastic. When it melts, it'll allow the tank to breathe. That's not an emergency vent. Okay, but in this case, nothing is right in terms of the installation of the tank, how the piping was configured, how the how the tank was venting. Everything is wrong there. Unfortunately, this is what we typically see as a common day tank for emergency generator systems. Now, piping, and tightness testing. Let me go first off regarding tank tightness. Everybody please be aware that my day tank has a completely different protocols regarding testing and also the sequencing. We have to test the day tank, it's an above ground tank, when it is finally in position at the building, not at the factory, not out at someone's shop. It has to be after it's installed. Then we can do the pressure test. If we move it, we have to do another pressure test. If we change the fuel out of it to a different class, we have to do it again. And in some cases, under the schedule of inspections, we have to do subsequent pressure tests. Now, the pressure test, here is a plain vanilla 500-gallon day tank. One of my guys was in here. It took him 20 minutes to reconfigure the piping to do a pressure test on this particular tank. So 20 minutes, he undid the fittings, closed the pipes, capped a couple things, and he has everything ready to go. This is a single wall tank, so it is a 1 hour test, 20 minutes to set up, 1 hour to do the test, another 10 minutes to take it to reconfigure it back to the system, to the way it was oriented when he got there. So in less than 2 hours, he had a complete pressure test as required by code, completed on this single wall tank. This is a double wall day tank, which has a controller on the top with the multiple floats hanging down. This took one of my guys 6 hours to do. Unfortunately, you see he has to literally pull this area here where you see the blank. That is where the float controller is hanging down. We can't test it with those float controllers on there because they don't hold pressure. So as a result, that must be pulled. We must put in a blank, and that's where all the time is, creating a blank that will seal that up, and then we do the pressure test. So please, big difference on these small day tanks and these larger systems as a result of having to create these blanks to seal them up. Now, the next thing is that the tank codes. What are the tank codes for inspection? Here they are, but the most critical one is the STI SP001 inspection standard. That's the one for shop fabricated tanks. That's the one we're going to be using the most. Next item, piping codes. Unfortunately, at a lot of sites, the piping is not per code. What is the piping that's supposed to be out there? The answer is ASME B31 power pipe, steel pipe. Okay, steel pipe is supposed to be what we're supposed to be using out there. Here you see a properly installed supply and return line going into a day tank. Everything there is fine. Schedule 40 steel, everything there is great. Unfortunately, we go over and we see that other sites where the connections are absolutely not per code, nor are the materials. Low melting point materials, we're constantly seeing copper tubing, brass and bronze valves used where they are legal for small heating systems above ground, or class 3B liquids, they're not for diesel systems. Everything is wrong here. You have copper sweat fittings, you have a bronze valve, you have a brass check valve, you have a water irrigation, that's for a lawn sprinkler system. That's what they're using for their anti-siphon for solenoid. Everything is wrong there, very common to see that. Here is an appropriate use of low melting point materials in a 2 hour box. We can do that there, or we can do it underground. Now, in terms of piping, there's a lot of problems about piping. Piping has to be protected from settlement, vibration, contraction, and expansion. Here you see on the top, this is literally people stomping on, it's in the middle of the sidewalk, that supply or return line, whichever it is, as opposed to on the lower side, you see we've got it configured with a cover to eliminate the damage to the piping. We also have the issue of flex connectors, pressure and thermal relief, oil safety valves, bollards, and even the supports. Supports have to be per code. None of that is being done at many sites you're going to go out and see. I'm showing you two different types of flex connectors. On the right is the underground only. On the left is an above ground. Underground is crimped together. Above ground is welded together. Inside and above ground, it's all corrugated stainless steel. Inside and underground, it's plastic. We cannot use those above grade. Here you see an emergency generator system, two flex connectors. They're both, you can actually read the label on it, underground. They cannot be used above ground as a result of not being fire rated. Proper supports of piping. And here I'm showing you MSS SP69 rated pipe supports. These pipe supports do not cause damage to the pipe from crevice corrosion or from faying attack. That's the way they're supposed to be installed per code. Okay, how are fuel pipes supposed to be marked? NCA 13.1. How are what the marking, how's the size of them, the labels, the colors, that's all in there. No galvanized piping can be used on a diesel system. Diesel systems are completely verboten for any aspect of galvanized. Give you the listing of the codes that mandate may never be galvanized steel. Okay, we have tank room issues. We've got a tank inside of a room, the day tank. What about fire extinguishers, curbs, and sealed floors, the fire ratings, the wall openings, and also the fire diamonds? Here you get the issue of what type of fire extinguisher you're supposed to have. Here we have the fact of how the floor is supposed to be laid out, including the curbing. We go in, and again, these hospitals and office buildings where we've had fuel come flowing down the hallway. The fact is the reason why we saw it coming down the hallway is no curbing, no sealing of the floor to the walls. Again, here you can see on the upper photo, the seal of the masonry floor to the masonry walls. On the lower one, you see the curbing that we have around the door. That's what you should be seeing. Other issues is the fire rating of the room itself, not having any combustible materials inside there. Any opening on the walls of a tank room. You have a day tank inside of a room, that is a tank room. Come on, basic things here is that a tank room contains a fuel tank. So therefore, we must protect the rest of the building from that fuel tank, including a fire. On the lower one, we have the fire damper. The upper one, we don't. So that's the both of the upper one is clearly what we don't want to be seeing, and unfortunately, we normally do in a tank room. The tank room fire diamonds, please. The fire diamonds are quite critical. They're on the checklist of most inspectors when they go out there. The sign does not have to be on a tank. Everybody's familiar with the blue health, red flammability, yellow reactivity. The size of the fire diamond is a function of how far away the first responder will actually see it. Here you see two fire trucks coming up to an emergency generator building in the back of an office building. Those are, where are they going to be seeing it? It's when they turn the corner. When they turn the corner, they're going to be 100 yards away from the building. The fire diamonds are on the outside of the building, not the inside of the building. They need to approach that building knowing that we have 80 gallons of diesel fuel inside that day tank. Here we have just a mechanical room with a day tank in it. Once again, I need that sign up there. In this case, the fire diamond must be next to the door, not on the door, not behind the door. Okay, fuel control issues. The biggest fuel control issues are overfill. Please, 2/3 of my releases regarding above ground tanks relate to spill and overfill. Overfill is number one, manual stop, remote alarms, tanks filled by pump, valving release control, and also maximum tank sizing. Here I am in an incident where we have an office building. We've got a single wall tank, day tank on top of the roof. The only thing that this tank has is fill control. As you see right here, that conduit coming down, that's coming down to a float inside the tank. As the float goes down, it activates the pump down in about 5 stories below me in the basement, and that 5 stories down, that's where we all of a sudden have the pump turns on and the fuel comes in. There is no valve here. That fuel fill is coming in. That little float got gummed up and unfortunately got stuck. And at that point, 10,000 gallons of number 2 diesel fuel came out of the emergency vent and the normal vent on top of the roof of this building. Here is how that tank was configured. So you see the float switch, and we've got the pumps that are remote are bringing fuel into this tank, but there is no overfill control. That little solenoid that they have there, and again, that's another issue regarding, can I have a solenoid there? Do I not have to have a solenoid? Some cases, yes, sometimes no. The issue here is that solenoid is fill control. It opens up only when that float switch is low. Unfortunately, the float switch gets stuck, the pumps turn on, and that solenoid valve is open. There is only fill control on this site. The fact is about how if I have pumped filling of the day tank, which is what we've been describing in so many of these instances, you must have a high-level alarm, a high-level auto shutoff valve, and an overflow line. You need all 3 of those are required for that day tank inside of a building. Now, on this case, you see all 3. This is my float switch for the fill control. Here is my overfill valve for my overfill control. Here is my overfill alarm, and there is my overflow line. Sometimes that overflow line has to be pumped overflow. We just make sure that the overflow pump is stronger than the filling pump. Okay, the day tank overflow requirements, again, I explained that the issue of if gravity is possible, otherwise we use a pump. The actual tank room. What are the issues regarding the tank room as to how it has to be laid out? The fact is that we have to have an emergency stop in the event that my tank, my emergency generator is greater than 15 kW. The emergency generator at my house is 25 kW. So please, 15 kW is a very tiny emergency generator. Most of my hospitals and office buildings are all measured in megawatts. Here is outside of the emergency generator room of a hospital. There's generator 1, generator 2. This is shutting down the diesel engine. Please, it's been around. This is not something new. This goes back to the 70s. Here is a emergency generator with a genset tank. The emergency generator shut off is over here on a wall just around the corner from it. My roof emergency generators, all the issues regarding how that has to be installed, how that has to be configured, all the requirements for distances of my setbacks, no combustible materials around them. Then we get into the max sizing. It's a function of how big the tank is as to what the hourly requirements for the fire code are. Here's an example of 660 gallons, either one or multiple tanks. The fact is that we are usually under the 1 hour requirement. When we get multiple tanks, we're limited to a maximum of 1,320. So a single emergency generator, maximum 660 gallon storage in the tank room with the generator, otherwise 1,320 stop. Now, again, what are my requirements for a room that's less than 1,320? How about greater than 1,320? How about my spill control? All those issues are just listing down here. Now, we still have to have valves to control pipe break. We've already mentioned about the solenoid valves. We also want to talk about fire valves and oil safety valves that are mandated by code. An oil safety valve, if you're not familiar with it, that is a negative control pressure valve where in the event that the pump does not turn on, that valve will not open. It only opens if downstream pressure is negative. In other words, my pipe is good and my burner of my diesel engine pump is turned on, creating the negative pressure. Otherwise, any damage to this line, the oil safety valve will never open. That's a requirement. Okay, venting always has discharge outside. I'm not going to go over venting since we just don't have the time on emergency venter and the size of them. We get into the maintenance issues. On maintenance issues, we have to have the fuel, clean fuel requirements. We have to have the fuel aging requirements. My annual testing, fuel does become contaminated. How does it come contaminated? The next issue is how do we keep it clean? I'm sorry, you can look through all this. What we normally are doing at most emergency generator facilities today is putting in fuel conditioners. Problem, fuel conditioners use a fuel pump to pull fuel from the tank and then send it back. If you have the system laid out incorrectly, you could literally overfill a tank as a result of getting conditioned fuel from another one. Again, my maintenance issues, SB0001. The Steel Tank Institute is basically the law of the land that we have as required under 40 CFR 112 as to all aspects of the system being tested, inspected, how we're doing. This is under the fire code, my very comprehensive code requirement for all the things that must be checked on a weekly, monthly, and quarterly and annual basis. This is some of the gluck that came out of an emergency generator main tank. The issue here is the main tank was not having the fuels tested, not having the fuel checked. This is what the emergency generator fuel looked like after a few years. Please, can I recommend for anyone installing tanks or even looking to see how they're supposed to be done, go to recommended practice 1400 of the Petroleum Equipment Institute. Now, last thing is, wrap up. Things are changing. The fact is that we've got the state and federal are coming in, recognizing that we've got to be looking at these day tanks. We've got to be looking at these emergency generator systems. Insurance companies are even requiring code inspections. But please, I want you to go take away this from this session that a heating oil tank, a Dunderhead heating oil tank is nothing to compare to an emergency generator. Now, further, the releases that we have from our day tank system tied down to our emergency generator are usually pretty significant because they're above ground and often inside a building, a very sensitive building like a hospital, like a residence, high-rise apartment complex, things like that. The next thing is about enforcement. Things are improving, but my problem is that we need more and better enforcement by trained personnel. You cannot regulate, you cannot inspect what you don't understand. Please, for inspection, any inspector going out there, you got to have classroom to understand what on earth is going on. It's got to have real world problems. It's got to go over specific pieces of equipment. In this case, this is our training center in Baltimore, where we take you out to mock tanks and we go through every single aspect of how the system should be installed. One of the items that's a requirement for some of our classes is, this is a gentleman who is a compliance inspector for a Midwest state. He had never tested a above ground storage tank alarm system. Well, all you have to do is just pull the probe and simulate overfilling of the tank by moving the float up and down. Again, go to a class where you can find this out. This is, I just want to inform you that the next Steel Tank Institute inspector course, the certified inspection program, is August 17th to 21st in Atlanta. I also want you to recognize that class is not full. Nothing beats a contractor complaining to a compliance officer than the compliance officer saying, I'm an accredited above ground tank inspector per the Steel Tank Institute. Read the EPA's 40 CFR 112 as to what that means. Also, the next class after that is October 19th to 23rd at our training center in Baltimore. So please, any more information that you want, please give me a call. Sorry, this was hurried, but we needed to cover a lot of things so that you would recognize what you probably don't understand, and therefore you're going to fill that gap by learning about it. That's what I've got, Nick. Back to you.
Great. Thank you so much, John. Really do appreciate that. With that, we would like to open it up for questions. And again, if people want to go ahead and send questions our way, addressing any questions to a speaker, that would be very helpful. So looking back, see what we have now. Looks like we have a question.
Got a question handy here. I was just kind of looking at.
Yeah, go for it.
So John, for you, based on slide 90, I don't know if you have the numbers handy, but based on slide 90, a ball valve has to be installed in a piping run that is in a concrete trench in a building. Would the trench have to be liquid tight to be considered a containment sump if a containment sump does not exist?
Okay, that's actually a regulatory question. I'm sorry. In terms of code, there's actually flexibility on it. But unfortunately, in most of the states that I work at, we actually have the state requires that, yes, that has to be meet all the requirements of a containment structure. Sorry to give it to you answer in that way, but it varies from state to state as I go up and down the East Coast and West Coast.
Sure, no, understood. Got another one right here for you, John. This person says they're glad they got to participate in your SP001 course a few years back. In one of your last slides showing a 660 gallon max, is that a maximum tank capacity for a genset, which is only applicable when it's enclosed inside of an occupied structure? Or is that because it's a structural limitation of the tank due to the weight of the generator?
No, that's strictly code. So there is, the only reason why we have that sizing requirement is the fire code. So I cannot take a tank room above 660 unless I have more than one generator. When I have multiple generators, I can go to 1320. Now, can I also take you to another conflict that in the code, there are also limitations for my max storage total on the site, either underground or above ground. But we have the issue of the 96 hours of continuous fuel. At some hospitals, we go shooting through 50, 60, 80, 100,000 gallons are needed to meet that requirement, but we're not allowed per code and local regulations to store that much fuel on site.
Got it, thank you.
All right, I have a question, this one for Tim. How does an owner operator conduct inventory control on a single wall generator UST system while with supply and return lines?
Hi, can you hear me?
Yes.
Yes, good. Actually, I would have to look at that. The inventory control requirements are no longer really applicable to the US systems. They're kind of been phased out that 10-year requirement. It's been a while since I looked at the inventory control manual, but I can write that question down and provide an answer later. If that's okay.
Okay, great, thanks. Drew, did you have a question lined up?
Yes, I did. A lot of good questions, folks. So sorting through here. So back to John. The question is, do solenoid valves need to be steel? All valves do, but do solenoid valves need to be steel also?
Okay, the issue there is the whole low melting point requirements. If I have it inside a 2-hour enclosure, I can use brass and bronze. If I'm not inside a 2-hour enclosure, almost every code requires that I cannot be using low melting point materials, and I have to go over to steel, usually stainless steel.
Thanks.
All right, question for Tim again. When does installation start? When ground is first broken, or when a tank is purchased, or is it some other time?
That's a good question. I think based on the component it goes in, there might be a different start date. But I believe each individual jurisdiction would have to make that determination. I don't think the feds have made any specific determination that installation for purposes of the regulation, it starts when all lines are put in. And the facility goes, the first day. So that might vary based on jurisdiction. I don't have a national, federal answer for you.
All right. I think this next question might be for Seth. For suction systems and return lines, will the 3-year line tightness test be adequate for return lines to meet compliance requirements?
Yeah, in Montana, the return lines that are gravity, we allow the 3-year line tightness test. But if they're having a discharge pump or discharge via pump, then we view that as a pressurized system, and then they would have to have the 0.1 line tightness test or a monthly piping leak detection method. Most commonly, that would be interstitial monitoring with a containment sump that would need to be tested every 3 years, because that interstitial monitoring method would be primary. And also, if it's an energy access system, then they were required to function test that sump regardless if it's primary or not with the piping interstitial monitoring.
Okay, great.
I've got one maybe for the panel here, maybe starting with Tim, but interested in the panel. Is there any requirement to run the system to assure that it will start when needed? And they say in this state, when EGENs were required, they put into place the requirement to periodically test the system, and the person said they didn't hear anything about that system testing to assure the generator will start. So any feedback from the panel on that, testing the systems?
John here. Yes, the NFPA 37 has all the requirements of the typical startup and also the semi-annual requirements and the annual. There are even load testing requirements. So depending upon the classification of the facility for the emergency generator, in some locales, we actually have to put a load on that generator, not just run the diesel. So please, that's all a function of local fire code.
This is Tim. There's nothing specific to the federal requirements that says you have to, start the system up tested. During the installation, after meeting RP 100, that would be the time frame, whatever is established by RP 100. That's how I would look at it.
Great. Any perspective, Seth, from your state as far as periodic testing? Sorry, periodic running of the system.
Could you say the question again, Nick or Drew?
I might have actually deleted it, but the gist of the question was, are there requirements, like in your state, we can say, are there requirements to periodically run the systems?
No, that we don't currently have any like fuel quality requirements or continuous system run for emergency power generators in Montana.
Got it. Thanks. Nick, we got a couple minutes left. I'll bump it back to you if you got any that you flagged.
Sure. So I do have a question here. I think another question for John. Are the codes or the regulatory requirements testing on fuel quality? Sorry, that actually might not be the one I had flagged. All right, here's a good one. For Tim, does EPA consider day tank to be part of the UST system? I think this is more of a clarifying question.
Yes, if the total system calculation meets that 10% below grade, then that day tank is regulated under 40 CFR 280.
Could I also add that not only that issue, there's another one under the fire code regarding the fire code for many years has stated that it must be the day tank. It has to meet all the code requirements if it's 60 gallons or greater. Unfortunately, the 40 CFR 112, I'm sorry, UL 142 has changed from the 60 gallon requirement to 20 gallon requirement. The UL 142 is referenced in NFPA 30, 40 CFR 112, all the fire codes. So therefore, everything is going to be going down to 20 gallons very shortly.
Okay, great. You have a couple more questions. For Seth, does Montana regulate both underground and above ground piping runs that service UST and ASTs?
Yeah, we regulate any regulated product piping that's underground in Montana, even if it's connected to above ground tank. The above ground tank requirements specifically that we have are just related mostly to the anti-siphon device. So as far as leak detection, we're looking at from where the piping enters either the containment sump or below ground, and then goes underground to the dispenser. For above ground pipes, if they have portions underground, then we regulate those portions. And that comes into play like at airports. Sometimes they have underground piping that goes above ground and then goes back underground. So there we would regulate those piping runs.
Okay, great. I think this question is for John. Can a vent come inside the building and then back outside?
Yes, in terms of the actual piping, it can, so that we actually have an enclosure on a roof area with a vent coming off of a day tank. But to get it literally above and meet the 2-foot clearance for the roof, we literally take it through the wall and then above the roof. So yes, it can, but with no openings between the tank and the pipe and the release.
Okay, great. Let's see, what's a good one? Question for Seth or Tim. Somebody were looking for a little bit of clarification. Are there any alternative release detection options that do not include the installation of ALLD when STPs are installed on an EPG tank? Would it be allowed for 24/7 audio-visual sensor alarm or a double-walled piping that slopes back to the sump? Annual testing of the lines and sensors or positive shutdown of turbines if sensors are in alarm?
This is Tim. That's a very good question. I alluded to or talked briefly about an AIM system guidance, and the whole, for probably about 30 years down, the program's been, trying to address can some sensors be used for the interstitial monitoring requirement? How can they be used? And that guidance pushes that discussion forward. It's not going to be a cookie cutter. If you do X, Y, and Z, EPA allows it. Owners and operators still have a responsibility, as they have for other release detection methods, to verify that the system that they use meets the release detection requirements. But what the guidance does is identifies the components like a tight interstice, tight piping that's required as a foundation to meet the requirements. So there won't be a necessary for these emergency power generator systems to install a line leak detector, but that closed system, for example, one of the categories I mentioned earlier about AIM system, pressure vacuum, those things are tight. If they lose pressure, you have that continuous system approach that's identified a suspected release. It won't work. As I mentioned and alluded to, there is that category 3 system with the sump sensor. It's not as foolproof, so there's some more controls with that. Shorter pipe runs allowed potentially. But the short answer is that there is some hope on the horizon for these emergency power generator systems to not necessarily have to install a out of the box like Veeder-Root, PLLD, or line leak detector. The federal regulations basically says the line leak detector, it doesn't really describe it, but as long as it meets that 3 gallon per hour at 10 psi, within that 1 hour, it can be used. So a line leak detector, automatic line leak detector, that's a pretty broad term. We've kind of gotten used to just the Veeder-Root XYZ or Franklin fueling, component, but the line leak detector, as long as it meets the federal definition, it can be used. And that could be a combination using a continuous alarm system. So hopefully that helps.
Great, and I think it does, but with that, we will probably have to wrap up now. So I will pass it back to Drew.
All right, great. Well, with that, we've come to the end of the webinar today. I'd like to extend a huge thank you to Carolyn, Tim, Seth, and John for speaking today. As a reminder, the webinar will be posted on the new EPG UST webpage. There you can also find, as you can see on the screen, multiple resources. Our UST inspector training webinars are there. Our LUST corrective action webinars are there. The complete archive of the LUST line bulletin, as well as information about the future 2021 National Tanks Conference that was mentioned at the beginning that was postponed. So as a reminder, please do take a moment to provide your feedback using the evaluation form. You should be automatically prompted to that after you close the window today. And some folks asked, you will receive a certificate of attendance via email. Sometimes it takes a couple days to come in, but that should be coming as long as you were on today to the email that you registered under. So with that, thanks everyone for participating in today's webinar. Hope that you join us again in the future and have a wonderful day.